It's kind of a stacked deck.
Best ever. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
I'm Dan Maloney.
This is episode 255, Balloon on the Moon, Nanotech Goblets, and USB all the way.
255. Very auspicious.
It is, huh?
For those who think in base 2.
Well, there's kind of a tradition, when you reach these big round number milestones of celebrating them. And we were thinking, what's the roundest possible number? And the answer, of course, is going to be next episode, which I think secret code name episode 0.
I was actually kind of disappointed when I found out I was going to be on 255 and not on 256, but then I realized 255 is a lot more interesting than 256, because 256 is just 100 hex, boring, 1000000 binary. Right now we're in FF.
There's all those ones.
FF is awesome, and 11111111 or whatever it is, 8 ones. I like this one. I like 255. I'll take this one.
It's the highest number it's ever going to get to. 8 fingers, there's no way to count higher.
You lost 2 fingers? I had no idea.
Well, you don't use your thumbs.
Oh, okay, right. Good point. Yeah. What kind of savage would use his thumbs?
Count on your fingers. Yeah. In honor of episode 256, next episode, we were trying to think of what fun things we could do, and we thought we'd have an Ask Me Anything. So head on over to hackaday.com/podcast, and in the comments of episode 255 that you will find there, write us some questions. Anything you want to know about the podcast, about Hackaday, about anything. It's an Ask Me Anything, and we will do our best to answer it. And so we're going to try to all convene at the same time, do a little roundtable, and answer your questions as best we can. All of us podcasters, me, Dan, Tom, Christina, Al, we're going to all get together virtually.
That'll be fun. We've never done that.
It will be fun. Yeah. We haven't ever done anything like that.
Especially if we do it like Truth or Dare.
It might be an Ask Me Anything, but we may have to reserve the right to how about Ask Me Anything Reasonable?
AMAR.
Yeah, exactly. I'm super looking forward to seeing what you folks out there will come up with. So yeah, ask us some good ones. If you fail to come up with good questions, what, can we make up our own?
We'll make up something, yeah. I mean, it's what we do.
Well, we can make it. We can pretend. No, that would be deceptive.
We'll have ChatGPT ask us something.
Yeah, so now there's a threat. If you don't ask us some good questions, we will have ChatGPT come up with questions to ask the Hackaday podcast hosts.
Please don't let us resort to that.
So all you natural intelligences out there, head on over to hackaday.com/podcast and shoot us some questions. And, I guess it's a question too. It's time for What's That Sound? Because What's That Sound is a question.
Good segue.
This is a journey into sound.
What's that sound? What's that sound?
Oh, wow. Oh, man, what? Oh, man, I know this, but I don't know
You
it.
do?
I know I've heard it. It's from a video game, from an old computer game, I should say. It feels like something that I heard on my friend's TI-99 that I don't know what we were playing. I don't know what the game was.
Arcade game?
I don't feel like it was an arcade game. I feel like it was, I heard this in, like one of my friend's bedrooms with a whole bunch of us laughing and joking around about this stupid game we were playing.
It is the intro to, drumroll please, Donkey Kong.
Is it?
Yeah. Yeah.
Okay, all right.
That boo 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 is where he jumps up and down and he knocks
jump up and down and knocks everything to everything goes cattywampus.
Yep.
Yeah, okay, all right. Wow, bad me.
And the bit at the end that sounds like some kind of bad alarm clock is, I think, supposed to be him growling or something. But
Yeah,
those were simpler times.
That's funny though, because now that you mention it, I can picture the arcade where I first saw Donkey Kong being played, and I was like,
Super.
what the hell is this?
Yeah.
I was used to things like asteroids and pinball machines and stuff like that, and I walk around and what's with the gorilla? What's with these ladders? What? I got with the program eventually. Apparently not well enough to get the what's that sound though.
Last week Al was on and he also didn't get it, but he pulled up Commander Keen, which is some super old video game that I've never played. So I gotta catch up on that one. But our listeners out there definitely knew that it was Donkey Kong. There were 66 answers. Oh no, 64 answers.
Oh yeah.
Oh, speaking of round
Nice.
numbers, congratulations,
Nice.
y'all. Of which I think 55 are correct. So the number of wrong answers is extremely small. And what's funny is they're all, of course, video games, right? But we got 2 votes for Wizard of War. We got 1 vote for Pitfall, which is awesome. Ghosts and Goblins got 1. What was the other one? Mario Kart? Arcade Mario? Nope, not that either. And 2 votes for Where in the World is Carmen Sandiego? Which is
that
pretty
little
awesome.
last part is kind of like the music, so I get that.
So super answers. Everybody else was like versions of Donkey Kong. So congratulations to, well, everybody else.
You got to get your 64-sided dice out.
Yeah, right? What am I going to do here? This has to be a computer one. There's no dice this big. Oh, there's got to be a website. We'll go random number generator. What I do? Okay, we're going to random.org because they are one of the oldest random number sites on the internet. I presume that means they're trustworthy, right?
Probably, yeah.
Minimum 1, maximum 55. Generate. Drum roll, please. The result is 24. That's also kind of a round number. And number 24 is Ed from Virginia. Donkey Kong, all caps, 3 exclamation points. I put enough quarters in that arcade to send someone to college. Fantastic answer. And congratulations, Ed from Virginia. I'll get in touch with you and we'll get you a Hackaday Podcast t-shirt. Toot sweet.
It paid off after all these years.
Yeah,
But the
right?
long game, right?
Yeah. See, wasted youth. No, sir. No, sir.
No way, man. It all comes back eventually.
All right, so let's start off with the hacks. And of course, as always, I'm starting off with a newsy article. This is Ingenuity may be grounded, but its legacy will be grand. And this was a write-up by Eric Berger at Ars Technica. I guess the news behind this is that Mars 2020, codename Ingenuity, the little helicopter on Mars, it is grounded forever. But this is after, 72 missions?
Yep.
And, well, I guess originally it was planned as a tech demonstrator to run 5 missions. And then once it's done proving that out, they then call it an operations demonstrator, where they basically just run it as long as it's gonna and see what they can get out of it. And that's part of what's really cool about Ingenuity, is that it was kind of a let's test this out, see what we can get out of it, and what they got out of it was a lot. The write-up over at Ars Technica says that this is a big win for using commercial off-the-shelf parts. And the coolest bit of that write-up, I think, for me, was that they used a cell phone processor on the thing instead of the kind of traditional rad-hardened, very expensive, very heavy microcontrollers that they usually use. And he actually says that the little Ingenuity helicopter has more compute power than JPL has ever put in space before on it. And that sounds good, but, in the end, it's like a 2015 Snapdragon processor. It's like, your phone's probably better. So, that says a little bit something about the demands that NASA puts on things for kind of mission critical computers, right? It's that everything has to be like hyper tested and rad hardened. And for this, they couldn't do otherwise because the rad hardened hyper tested part weighs a ton. And this one, it's a cell phone part. It weighs a couple grams. So there's obvious mission reasons that they went with this. The Ars Technica article says that this is going to maybe start off a wave of using regular old commodity parts up in space. And I think that's an interesting idea. It certainly is cheaper if you do it that way, as long as you don't count the price of getting it up there in the first place, which I think is actually still pretty serious. If you look at,
Yeah.
I don't know how many missions you've flown to Mars, but I think it costs a fair bit to get the payload out there. So I'm not 100% sure I buy the article's premise, but what I really do love about this is it points out the kind of fantastic successes that NASA has when it rolls the bones, when they push their technology demonstration missions out there. And I think a lot of people don't remember, but the whole Mars rover actually started off with a tech demo. You know, they put up a cheap, small, semi-autonomous remote control vehicle and wanted to see how it would do. And then for the last, 20 something years, we've been putting fancier and fancier robot vehicles up on the planet. So, they've got a track record of doing this and turning these tech demos into cooler and cooler things. So I thought that was a neat part of this too. And that actually wasn't the Ars Technica article. That's just me spitballing.
Pretty sad day when I saw the news that Ingenuity was grounded for good, and I'm actually writing up a story on kind of my thoughts on anthropomorphizing technology and what purpose it serves, because I think it does serve a purpose. But that's probably come out soon. But the thing that really got me about the whole process is there's that picture, the classic picture of Perseverance and Ingenuity in the same frame, posing for a selfie after Ingenuity came out of the bottom of the rover and the rover moved away back when it was, first deployed. It's interesting to me because the thing that brought the technology demonstrator to the surface was itself a scale up kind of like you said, like a previous rover. I think Sojourner was the first technology demonstrator rover. It makes me wonder what the next, what the inception kind of thing of this is. Now take the Ingenuity, has proven itself as a technology demonstrator, and what will the next one look like when you look at the difference in scale between Sojourner, which was the size of an RC car basically, and now you've got this thing that's the size of a Volkswagen running around Mars and spitting out helicopters and picking up rock samples and doing all kinds of stuff. So what's it going to look like when NASA puts the next helicopter on Mars? Is it going to be gigantic and have all the processing power and do all the things that this little tiny helicopter couldn't do? Probably. That seems to be the way they progress. What's the technology demonstrator of that going to be? What little project is it going to poop out along the way and have it fly off and have, a cell phone processor in it or whatever they do, what's that going to look like? And all very, very interesting progression of technology. And come on, hats off to everybody involved in Ingenuity for getting it 72 missions into a 5-mission slate and, pulling off some really, really cool stuff. Okay, my first pick is a little more down to earth. It's Vintage Monitor Lives Again with a New Heart. This one is Adrian over at Adrian's Digital Basement, who had come upon, as many of us do, a whole host of junk stuff. Again, I'm going to say it. I don't hang out in the right dumpsters, apparently, because everybody else comes up with this great stuff. He found an old TV, a 13-inch color TV, and that was a real popular kind of form factor for TVs, back in the days. He figured this one was from around the year 2000, so just before flat screens became the big thing. The TV itself, he didn't care for the way it looked. It was kind of bulbous and plastic looking, but it seemed to have enough parts in it that he could maybe do something interesting with it, which was to fix a Commodore 1702 monitor. These things were great. Back in my Commodore days, I would have killed for one of these things. Instead, I had a 12-inch black and white TV, which was my monitor. But these things were beautiful because they, that you didn't go through the RF modulator. You had a nice, crisp, clear color display. Things were, the 1702 cost probably 3 times as much as the Commodore 64. So there was no way that was ever going to happen for me, but he has one lying around in his basement, and it's seen better days. The CRT was in poor shape. Things probably would have dated from what, like the mid 80s, early 90s at the latest, I think you would. So this thing had a lot of miles on it, the 1702. The TV was in a lot better shape, and it just so happened that they had about the same sized CRT, and it made it sort of a no-brainer to try doing a tube transplant. The other part of this that was interesting, and I had no idea such things existed, was as a completely separate project, he had ordered from Alibaba a main board replacement for color TVs, which has pretty much everything, the whole video front end, the high voltage stuff, the deflection circuits, all of that built into one module that you can slide into a chassis and have a TV if you happen to have a tube. Well, he happened to have a tube, so he managed to get this board, which was roughly the same size as the original board in the 1702. Still needed some modifications to fit into the metal chassis that was in the original monitor. Hey, it worked. It was able. You're kind of stretching the definition of it's still a 1702 monitor at that point, because you've replaced the tube, the chassis, the main board. The only thing that's left that's kind of original is the case and the deflection coils. And he made an interesting point about the deflection coils. He said it's kind of important to use the deflection coils that originally came with the 1702 monitor, because the inductance and the details of their construction would probably interfere with the new electronics on the main board. But yeah, great restoration project. Lucky breaks all around to getting a tube that fit and this special board, this replacement board off of Alibaba, and getting everything just right to get this monitor back on its feet.
I definitely agree with I alone possess the truth, who says at some point this is just Theseus' ship. What's left of the Commodore monitor here? Just the case? And then F0, true, but the Commodore case and badge must surely count as the soul of the monitor. Oh, ouch, ouch, ouch. But I mean, I guess the point here is that the 1702 was a good monitor back in the day. It was a decent quality workhorse video monitor. And so, that's why some people have this kind of nostalgia for it. The problem is that, to my estimation, what made it so, of course, was all the guts and none of the case.
Yeah.
So this is a sweet project to have if you have a Commodore setup and you need something that looks like a Commodore monitor, right? So I'm not gonna, and what the heck, it was all stuff in his basement. I'm not gonna begrudge him any of this, and it made a good story. So really, you can't complain. But calling it a 1702 restoration or something would be a little bit of a stretch.
Little stretch, but hey.
But we didn't, so
no.
You clickbait callers could just go home.
Well, it sort of makes me wonder too. What is this going to be like? Is this going to be one of those things where the hipsters are going to save us, like they salvage vinyl records, and then finally they're going to take on to the ironic CRT TV instead of LCD, and then all of a sudden we'll have like artisanal CRT manufacturers like Dalibor Farney or something like that.
Somebody suggested that in the comments.
I know, exactly.
I love it.
Doing the stuff on the front of the tube, putting the phosphors on in, the dots if it's a regular CRT, or the lines if it's a Trinitron, the shadow mask, all of that stuff. Unbelievably complicated processes that I think we've probably lost that for good. It's a little bit like, the Apollo skill set being lost. We just don't have anybody around anymore that knows how to run the machines, if the machines are even around anymore, that do that put those tiny little dots of phosphor in just the right place.
The problem with manufacturing CRTs is that you have to really want to do it. Like, you have to be running a TV manufacturing company to want to step into that arena. And It's just not something that I think the home gamer is ever going to do.
Probably not, no.
Totally stoked to be proven wrong. And, I bet you $1 million we've seen someone do a homemade CRT project on Hackaday. Hold on. I'm searching this one.
A monochrome one, I think we have.
DIY phosphor CRT, building a CRT and bathing yourself in X-rays, DIY electron accelerator, build your own CRT TV. All right, let's see what we got here, folks. Rolling the dice. Okay, that's a terrifying one. The first hit is a building a CRT and bathing yourself in X-rays from 2012. It's a quote 1 pixel CRT, which is to say he's not steering the beam at all.
Well, that's a Crookes tube then.
Yeah, DIY electron accelerator, actually the same thing, except it's in a wine bottle. Cathode ray tube in a wine bottle. This is lovely. And
well, it would work for if it was a nice green tube or bottle. It would work for us like an oscilloscope, right?
and the last one is from 2012. Build your own CRT TV, but it's using the same AliExpress black and white TV guts to do exactly the same thing as is being done here. So it looks like we do not have record of someone making a CRT screen in Hackaday. So the gauntlet is thrown, ladies and gentlemen.
The gauntlet is thrown.
I'm going to paste these links in just in case you want to read. That one with the cathode ray tube and the wine bottle is fantastic.
Wow, that's going way back, 2011. Nice.
Yeah, we're going to go way back. But first, a trip to the future, or at least the near present. My next hack, getting started with USB-C and common pitfalls with charging and data transfer. This is a video from Andreas Spiess, who is the YouTuber with the Swiss accent. Grüezi. This is a great video if you want a quick primer on USB-C, and I just thought it was a superb explanation, and that's why I enjoyed it. I actually knew most of this beforehand, but that doesn't accept me from enjoying a really good explanation of it. This video is in principle about USB-C, but it's actually mostly about the USB-C cables. And just a few weeks ago, Tom was on the show and was like, oh, I love USB-C and blah, 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 blah. And I'm like, yeah, but its Achilles heel is the cables. And we both kind of agreed on that and then moved on to the next hack. This video takes that look absolutely seriously. And what I really love about this video and what speaks to our audience is that he takes the USB-C spec and says, this line does this, this line does this, this line does this. And when your cable is missing these lines, it can't do these functions, obviously enough. And so, for instance, there are data lines in pairs. There's the old USB ones for compatibility, and then there are 2 more lanes for getting higher speed data throughput. So if you're faced with one of these USB-C cables that won't do high speed data, it's probably just missing those wires inside of it. And he uses one of these nice credit card size, you plug the cable into both sides, and if the LEDs light up, it's connected kind of demonstrators there. More on those in a minute. The other trick that USB-C can do, which is completely separate from high-speed data, of course, is the power delivery side, where a chip in the powered device talks to the charger and says, give me 5 volts, give me 9 volts, give me 12 volts. And then the power delivery charger does so. And that's all communicated across these CC lines. He talks about that a little bit as well, and then kind of blurs the two together. And this is the part that makes me least comfortable with USB-C, is that a lot of the cables have an active component in them as well, the E markers, which say both how much data throughput they can handle and how much power they can handle. So you can imagine a cable with really thin wires doesn't want to run 10 amps down it. And a cable with thicker wires can say, oh yeah, I can handle that. And so that's where the E markers come in. You might think this sounds complicated, that there are all these cables out there. Some of them are missing these wires, some of them have extra wires, some of them have thick wires, some of them have thin wires, and you'd be entirely right. The way to get out of being confused by this complication, though, is to get a couple simple tools. And here he demonstrates one of the little credit card size USB-C testers that says, which lines are in there, which will let you know how much data it can push through, but doesn't help you with the power delivery side. And for that, he breaks out another tool. It's a KM003C, which I'd never seen before. It's really cool, actually. And that thing speaks power delivery and will then talk to the E marker in the cable and talk to the power delivery supply on the other side and enumerate all of the possible values. Costs $100 though, so I'm not going to be testing all my cables with that. On the other hand, the simple, like, does this thing have enough wires connectors is a project we've seen a ton of on Hackaday. And I'll throw the links for 3 open source variants of these into the show notes.
Yeah, this is pretty timely for me because I've been having problems with my phone. It's only, I don't know, a year and a half old, something like that. And it's just every time I plug it in on the nightstand to charge, it tells me, problem with a charging accessory. It won't charge fast enough or blah, 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 some Android message. And, I end up in the morning with, 30% and 10%, something like that on the phone. I've tried to figure it out, swap cables around. I've swapped chargers around. I've even, plugged charger into a different outlet. I can't figure it out. I don't know if it's the phone. I don't know if it's the cable. I don't know what it is. Something like that $100 power delivery analyzer might help me figure it out. I don't know if I really want to go that far. I think it actually probably comes down to the phone, and it almost feels like the USB connector is wobbling around a little bit. So I might have to just pop the screen off the phone, dig it apart, and take the USB connector off the main board. I'm actually kind of secretly hoping that's what the problem is. So I can use my microscope.
Give you an excuse. Yeah.
Give me an excuse to take my phone apart.
Andreas's conclusion at the end of this is that after having gotten these testers, he then goes through all of his cables and finds out that only a few of them do everything. And that is to say, only a few of them have all the wires for high-speed data so that they can cover the USB 4 standard. And only a few of them have thick enough wires that they can do power delivery with the right e-marker chips in them. And kind of this combination of features in a cable is what he's looking for. And if you've got the budget for it, I guess his champagne sipping lifestyle is the way to go. You throw all your old cables away and you buy only cables that work and do everything. But I think they must cost like $15-20 a piece.
Probably,
so,
yeah.
Might work for fancy YouTubers, but for Hackaday editors, we're gonna keep we're gonna have a look at the cables we have on hand. This is like the Achilles heel of the USB-C system, that they wanted to have one connector and one standard that does everything, but then the cables have at least 2 different standards, and maybe when you multiply those by the different flavors of them all, kind of 8 or 10 different standards. And that is, of course, a recipe for confusion, certainly among, normal people, but even among us, if you don't have the right tools to kind of look into what exactly is right or wrong with this thing. The fact that his active USB-C tester costs $100 is interesting to me. And this suggests that there's room here for an open source hardware software project to make the ultimate USB-C cable tester querier that reads the e-markers and knows how to talk to them. And it shouldn't be hard to put something together like that costs, under $7-8 in BOM cost. So, this is something we ought to be able to do, folks. So
exactly,
2 gauntlets in one podcast. Get on it. Actually, Arya Voronova wrote up a really great series on USB-C, and I think she got kind of 90% of the way to doing this. She made a USB interposer that you could program in MicroPython and read from. All that's lacking is then kind of the database of these bits from the eMarker reader say this, and a lookup for all of the different condition codes and stuff. So I think we're actually probably mostly there. Go back and check out Arya's USB-C series. I'll throw links in the show notes if you're interested in pushing this project somewhere.
All right, next up for me, a look at 3D printed professional LED signage. This comes from King Process. It's a video that shows the process of making signs in a sort of, I'm not going to say post-neon era, but neon is not available to everybody. It's just prohibitive, unless you've got, a big bucks. It's a beer sign that the beer distributor actually, sells you. Then they kind of subsidize the cost of that sign, something like that. Okay, most of us are going to have to settle for something else, and LED signage is really coming along. And I mean, I'm sad that there's less neon in the world, but these things look pretty good. The idea here is, in a Korean shop that specializes just in making these signs, apparently. They have enormous bed 3D printers. They're probably, I mean, if they're making a sign, right? So it's got to be a pretty big bed. It looks like maybe, I don't know, a meter square, more maybe. The XY direction is the big thing. The size of the bed is really the important thing. The Z direction, not so much, but you do need some depth to make these signs. I mean, it's just a regular 3D printing process. You've got hot PLA and you squeeze it out of a nozzle and there's no magic there. But where the magic comes in is the shape of these, I want to call them troughs, or I don't really know what you would even call them. But anyways, the signs are made upside down on the bed. The side that's going to be facing the customer is what's going down on the glass first. And they do the usual 3D printing thing with triangular cross section or volume that can be filled with silicone. The silicone goes in there, fills up this space basically, and gets cured in a light box. And then the whole sign can get flipped over and color can be applied manually with pigmented silicone on the front. Obviously, at the end of this whole thing, you've left a space at the back of it, and you can apply some LED strips to that, and you've got a finished sign. The whole process is fascinating to watch. The care that the workers are putting into these signs it's kind of notable how carefully everything is being moved from station to station, how, everything's being dusted and very carefully tended so that these signs come out perfect, and they look pretty good when they're done. I don't know if this is like the only job that this shop does, if they're just doing LED signs, or if they do other kind of signage like out of wood or metal or whatever. But they seem to put a lot of infrastructure in place for these signs, and it seems like they're kind of all over the place in Korea.
Watching the video, first of all, there's like all this like super triumphant music as this 3D printer is like slowly printing along. Absolutely fantastic. But no, this is a really cool technique and is something, like you suggest, that, maybe you could do at least some version of as a home gamer. You described it as a triangular profile is really neat. And they use a white PLA so that it, kind of gets side illuminated out the sides of it. And then then the rest is clever diffuser design and using silicone so that it lights up nice and evenly and bounces the light all around, and different color layers. It looks like they're using different dyed silicone layers in there. So they have a white diffusion layer, and then they put a color layer, and then they just have white LEDs on the back of it so that it shines through. You get all these different factors right, and you've got something cool looking, and there's nothing stopping you from doing something like this at home. This is totally normal 3D printing, and a little bit of pour some silicone in there, let it cure, pour some silicone in there, let it cure. It'd be a sweet looking effect.
Yeah, someone in the comments even said, hey, I wonder if you could make a 7-segment display out of this. Absolutely.
Oh, you could.
On pretty much any home grade 3D printer, you could just whip these things out right now. In fact, one of the comments in reply to that comment was from a very knowledgeable source, who guy we had on the Hack Chat who does props and movie effects. And so they know silicone, right? That's you got to use that stuff all over the place. And so go ahead. I would love to see one. I'd love to see a gigantic, whatever size segment you can get on a regular 3D printer, and then just print up 7 of those and figure out how to put them all together and then dazzle us. Another gauntlet. There we go.
It's the way the shows go.
The listeners are going to be busy.
Yeah, and I really love LEDs with good diffusers on them. And I think the silicone trick is a really good one. I think early on when we had RGB LEDs and they were all brand new, we were just like, I want more blinky. And now I think it's kind of evolving. Once you see these really smooth, really good looking, even illumination projects like this, it kind of makes you want to emulate that. And I think a lot of the secret here is just kind of some internal volume so things can reflect around a little bit. And silicone seems to be it. My wife and son built a colored LED lamp thing for me for Christmas, and it uses a flexible silicone RGB LED strip, and it's really neat. It's got kind of a U channel. The LEDs don't shine directly out at you. Instead, they shine across this U channel, and then the top of the U channel has a silicone bead over it. So all the light is contained inside this, white reflective U-shaped channel. It's never pointed directly out at the user, so it's all just kind of reflected around this internal volume and then diffused out through the silicone strip on the outside. And that is a great effect, and it works remarkably well at giving you a, what looks like a neon-esque. I mean, it's really just nice, even light, but works pretty damn well. I mean, this was obviously kind of artisanal sign manufacture, but the cheaper end of things is catching up as well, and you can get some really nice looking lights out of them these days. That's interesting. There's stuff to learn from the commercial crap as well as the, artisan sign manufacturers. The last one I'd like to pick this week is a long article by Arya. It's the beginning of a 2-part series on making USB HID devices. Redundant. This is the human interfacing devices, the descriptor heist. It's the first in a series of 2 on making custom USB devices. If you haven't taken a deep look at USB, one of the neat, interesting things is how the data gets sent across. So like you plug in a keyboard and the computer knows it's a keyboard. You plug in a mouse, it knows it's a mouse. How does it do that? And the answer is the USB device descriptor. And this is basically a set format that says, okay, I'm going to send you this byte and you're going to interpret it this way. And then I'm going to send this byte and you're going to interpret it that way. The descriptor is kind of just what it says, a description of what the device is getting ready to send to the host. And so you can say, oh, it's a mouse, oh, it's a whatever. There's actually a bunch of standard device types that are listed out in the HID usage tables. And this is one of the funnest, driest documents I've ever read in my life. I'm going to throw the link to the PDF in the show notes because it tells you, standard byte field descriptions are for like a baseball bat with an accelerometer in it. So if you want to make a baseball bat peripheral that you can swing in your virtual game, this thing tells you how to do it and more. There's medical equipment things. There's all sorts of crazy devices. It's really fun to think about all the crazy edge cases that they've already thought of. But also, if you want to make a random crazy USB device, the good news is there's probably a usage table for it. And so that'll tell you how you can go. But if you want to make a device that's maybe kind of a mashup of a bunch of these other features that are common on devices we use, that's what Arya's article is about here, which is how to get the descriptor files from your computer after you plug in a mouse, right? You plug it in, your computer says what you got, the USB device sends its descriptor across, and at least on Linux, you can just, using some simple Python libraries, USB HID Python library, you can read this descriptor report straight out and implement that in your own device. Say you want to make a mouse, or say you want to make a combo mouse and pointer, or whatever you want. You can just read these HID descriptors off of devices you already own, mash them together, and boom, you're off to the races. And she's going to demo that in the second part of this series, probably coming up next week.
Yeah, it's always a little bit of magic. Plugging in a USB device and seeing it enumerate.
I remember back in the old days, I made a couple joystick adapters and then a mouse and a bunch of HID devices. And I thought to myself, yeah, I'll just write my own descriptor from scratch. And I did that actually once successfully for a joystick. You can actually just read the descriptor standard and do it that way. But what Ari's suggesting here is you just find something like what you want and copy it. And boy, that is smart. That is a lot easier than wasting all your time with, look up the code for the button usage page, look up the code for saying it's a 8-bit number, look up the code for this. None of it's impossible. It's just a lot of dirty work to get these descriptors written up. So having done it both ways, I wholeheartedly suggest that you follow Arya's advice and just, if you want to make a scroll wheel, you steal a known good scroll wheel descriptor file and use that in your project.
Next up for me, nanotechnology in ancient Rome. There is evidence. Christina Panos is taking a look at the nature of the King Lycurgus of Thrace had these cups made back in the 4th century or so. So I guess not that early in the Roman Empire, but still real old. The gold's part of it, the metalwork part of it is, intricately detailed, very fascinating to look at and all that. But the glass is the real star here. It ends up being basically a dichroic glass, which should not have been possible to create in 4th century. But there it is. It exists. If you look at it with transmitted light, if you look, if the light shines through it, it looks red. When you are looking at light reflecting off of it, it looks green. And the way it does this is with a mix of colloidal gold and silver that's put into the glass before it's made into the glass part of the cup. The colloidal properties of the gold and silver are what make the dichroic property of the glass. And it's basically nanoscale particles of gold and silver. So the question is, how did they get there? Were they put in purposely, or was this an accident of some sort? Did they know what they were doing when they put these gold and silver particles in the glass? It's an open question. You don't really know if this is something they had control over, if it was just sort of a happy accident that someone noticed, oh, look, when I did the glass this way and I put this bit of something in it, it ended up being, green when you look through it and red when you're not looking through it. Was that something they had, they noticed that and then they said, okay, well, let's do that a little better next time. Let's do whatever we did and, try to replicate that. And they eventually found out that they could do that. Or did they really know, like, well, if we make nano-sized particles of gold and silver and put it in glass, it'll do this? Like, I don't think it's the latter. I think it's probably the former. But it doesn't make it any less interesting and any less beautiful. Calling it nanotechnology is probably stretching it a bit. It's using something that's at a nanoscale, but then again, so are smoke particles. And smoke's all over the place, and it gets used. I mean, you could smoke glass, right? You could use that to make dark glass, so you can look at bright lights. You could look at an eclipse through. Don't do this, but you could smoke glass and use it to look at an eclipse. That's not really commanding nanotechnology in any real way, but it's still a useful application of nanoscale processes. And it certainly seems like they knew what they were doing here, because it's so evenly distributed around the glass that there's no way that this could be just a mistake that got built into one particular cup that we have an example of. This was probably something that was done at scale, reduced to practice. They probably turned out a lot of these things, and we just happen to have one example of it here, and pretty gorgeous and a fascinating process.
Christina and I were talking about this one, and actually I ended up digging around looking for Lycurgus cup and Lycurgus cup effect to a really neat article from, I guess it was published in Journal of Nanotechnology. Gold and silver dichroic nanocomposite in the quest for 3D printing the Lycurgus cup, in which they do exactly that. They get a bunch of gold and silver nanoparticles and they mix them in with some PVA, make a custom filament, and they 3D print their own. It's absolutely fantastic, and it's entirely convincing and 3D printed. So really, really cool. The authors say the research started as a curiosity-driven research. Could we do this? And the answer is, why, yes, they could. And I think that's really pretty fun. The other thing Christina and I were thinking is, how the heck would the Romans have done this back in, 400 AD? So it's glass, right? So they make glass by melting sand. Sand's nice and gritty. If you want to grind stuff up to tiny, tiny little particles, sand's actually a pretty good thing to mix it with. So I was just kind of free speculating that they probably ground the sand somehow, maybe mortar and pestle. I don't know how you grind up silver into tiny, tiny little nanoparticles, ditto gold. But, mixing it with sand and just kind of grinding it around for a long time seems half plausible to me. And then you melt the thing.
I would bet that it's something to do with gold in solution and silver.
Ooh.
Oh,
you think they dissolved it first?
I think they dissolved it maybe because I'm pretty sure.
Oh, you're smart.
Pretty sure Aqua Regia was known at that time. Pretty sure, not 100%. I mean, alchemy's been going on for a long time, and that was like. But yeah, if you could get it into solution and then precipitate it, but only just barely, maybe you could make nanoparticles. If you had solid gold, even if you had gold leaf or something like that, very difficult with something that's so soft as gold and silver to some degree.
Yeah, you might be right.
How do you grind that? It's not gonna. I don't think it's gonna respond well to a mechanical grind. But I bet you a chemical process is probably where they came up with this. That points to intention for sure. That's that. You don't just go start mixing gold and silver with acids and just as a mistake, just spill that in your glass mix before you cast it. I think they probably knew exactly what they were doing here. They might not have understood the scale of it that like the way we do, but I think this is absolutely intentional. And maybe I'll go back on that. Maybe say that was nanotechnology.
They were definitely playing around with other colors in glass at the time. So there's additives to glass in all sorts of colors from that time period. So I bet you're right, and I bet they did. And yeah, you're probably 100% right that it was chemical. There goes my mechanical solution. Congratulations, chemistry.
You win again.
Damn you, chemistry. My first quick hack this week comes from the Smithsonian. Roman dodecahedrons, a mystifying archaeological find. This is a dodecahedron. It's like a 12-sided die with a bunch of different size holes passing through it and little knobbies at all of the corners. And the question is, what the heck is this thing? And there's all sorts of speculation. I have to say, I think the most convincing answer here was linked to us by Brad in the comments, and I'll throw that video in. It's a video by Amy Gaines, who thinks that it's a braiding jig, basically, and the different size holes are for putting different rods through to make different diameter chains out of. She compares Roman gold chains in museums to the kind of thing she makes out of copper with this, and they are essentially identical. So as far as I'm concerned, that's actually case closed. It's a braiding jig. How cool is that? Next up, Hans Gelke, a complete exchange from scratch for your rotary dial phones. This is wild. This is a talk given at the Chaos Communication Congress. And the question is, if you had to design a kind of low budget hacker telephone central switch office today, what would you do? And this is exactly the answer to that. It's really cool if you want to see how old phone exchanges worked or what you could do with a Raspberry Pi and a whole mess of JFETs today. This is a really cool talk. A mouse becomes a camera. Dr. Volt. This is a take on a really old project, which is realizing that the optical sensor in any old USB mouse is really a camera. All you have to do is add a lens. This is a really great dissection of how all that works. And then in the comments, someone, of course, linked a project from way back in 2006 by Sprite TM, where he did the same thing and even made it track as it goes across your desk. Really fun, but a lens turns it into kind of the worst, lowest resolution camera you've ever seen.
First quick hack for me is wearable robot makes mountain climbing a breeze for seniors. First thing I thought of when I looked at these was high-tech tighty whities. These are basically an endoskeleton that goes on the upper thighs, and it goes around the waist and then attaches to the thighs and has power joints that will motor you up a hill. It's called Moonwalk Omni. and it's designed to support leg strength in any direction. I like the idea, having been on many hikes where I've wished for just such a thing. However, the weak point for me has always been my knees, especially on the downhill. So I would rather support and power my knees than my thighs. And I also wonder what the value of this thing is when it runs out of batteries and you're stuck wearing it. It's just dead weight at that point. But still, kind of pretty cool. Next up from Pile of Stuff is Flux from Scratch. I'm going to admit it right up front. I love the smell of flux. I love the smell of solder smoke. I know it's not good for me, but I still kind of love it. This is homemade flux working from what looks like the kind of rosin that musicians would use to rosin up their bows. Pile of Stuff comes up with a formula for dissolving that in methanol. Isopropanol maybe would work too. Ethanol would maybe work, but for whatever reason he chose methyl alcohol and actually got some working flux out of it. So it's a nice little chemistry project to go with your electronics. Last up for me, No Dish. Try a portable weave helix antenna. This is a project that came out of the American University of Beirut and Stanford, working in collaboration to create a quad. Let me get this right. Quad filar hex antenna, QFH, that is collapsible and portable. Basically what it is a bunch of metal strips that are wound into a helix and attached to non-conductive helices in the anti-sense of that. The joints of all of the non-conductive and conductive parts are put together with flexible plastic rivets, and the whole thing can squish down like one of those finger trap toys. And if you had enormous fingers, this thing would trap you if you put your finger in it. But as it is, it folds down to be portable. You can extend it out to be a full-size antenna. It's just the kind of thing that you would use for communicating to satellites. QFH antennas are well known in that domain, but also has applications in regular omnidirectional radio communications.
All right, it's time for our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this week I wanted to pick Donald Papp's 3D printing. Speed is so hot right now. And it's true. I think in the last year and a half, 3D printers have gotten a lot faster. Donald starts this article off pointing out that there used to be a trade-off between speed and quality, basically. And those of us who wanted a nice-looking print would print slower. And, if you're just doing a draft and you just want it done quick, you could give up on some of the surface finish, not worry about the ringing and distortions and uneven lines and all that come across from going really quickly. Just get the thing banged out. And nowadays, it's not as hard a trade-off as it used to be. And this is due to what I think of as a whole constellation of different factors kind of all coming together at once. So on the kind of motor control and software side, there's input shaping, which gets rid of the ringing and ghosting that you get when you go around sharp corners with a 3D printer. Basically, you can think of it having to change direction really quickly, and there's going to be some slop in the system, and so the head won't turn a right angle corner. Instead, it'll kind of overshoot a little bit, and then it'll recorrect a little bit. And if something's a little wobbly, you get kind of this trailing off wobble as it goes around the corner. That's the ringing in question. Input shaping is doing clever math to make that work out a little bit better, so you command it to go a little short where it would overshoot, and then a little long where it would undershoot, and you smooth that on out in software. But if you just applied input shaping or some of these other tricks, you'd find that the printer couldn't spit out plastic fast enough. And that brings us to other software advances like Pressure Advance, where you kind of compensate for the fact that there's a bit of a lag between pushing the filament into the hot end and the filament coming out the other side of it. And so kind of getting ahead of the need for higher or lower pressure in the nozzle lets you get that part working consistently. And then still there's a need for higher flower nozzles, because if your machine is A, rigid enough, B, maybe using input shaping, and you've got the whole nozzle pressure thing figured out, you still have the problem that it needs to put out enough plastic to keep up with this. And this is a part that he actually didn't really mention in this article, but I think there's been also a lot of improvement in the last 5 years is nozzles that can do high throughput and keep up with these high-speed machines. Plus, a lot of machines have kind of a physically more rigid frame. We've moved away from a lot of these Prusa i3 style frames, if you know what that means. They're kind of an XZ plane and then a bed that goes back and forth along the Y plane. And they're just set up as perpendicular planes to each other. A lot of the machines these days are set up like a box, and that box is just physically more stable. The frame is much more rigid. A lot of them use a separate motion where the XY, which is a really strong axis, a really rigid axis. So it's really interesting. A lot of these different improvements kind of all happened at the same time and are kind of all coming together right now in the 3D printer world. And he mentions the Bamboo Lab printer as being kind of one of the first commercializations of all of these different developments that have been happening across the industry. And I think that's actually true too. It's an incredibly expensive machine, but they have got it doing all the right things. If you're interested in the kind of DIY version of all of this that they built on, you should check out the Voron series of machines. They're also these, square frames, linear rails, capable of really high acceleration, but then you also strap on a high volume print head and do something clever with the software and motor control side, and boom, you don't have to worry about whether you can print fast or print well. You can do both at the same time. And I will say that Dade comes in here. He used to work for Ultimaker. And back in the day, that was the fastest printer I think any of us had seen. And all of these modern versions are similar to that in the sense that they're also a cube setup. They're also an XY movement, very similar to the old Ultimaker. I'll quibble with him a little bit. The Ultimaker could move that fast and move that fast very well, but it never had the software to back it up, and it never had the high flow head on it that would let it print the same, final speed of printing. He actually mentions that in his comment. He says the limit of what kept the Ultimaker from going super fast wasn't the physical machine, but was just how much material they could put out through the nozzle. Could they put out enough plastic to keep up with how fast the machine was able to move? Nowadays, it looks like all the parts have come together, and you can.
The first thing I thought of when you were talking about this was, and I think even Donald mentions it, everything is a spring in physics.
Yeah.
I almost feel like the mechanical part of it, as far as moving XYZ and, moving the machine around, is kind of not solved, and not really a solved problem, but it's pretty close to it. I mean, we should be able to figure out how to move things around. Where you really are going to see the benefits is with the springiness of melted plastic inside of that, extrusion chamber. You're not going to get rid of that. It's a liquid, it's compressible. If it's compressible, it's got a spring moment. And I think that's the point where you're going to really attack if you want to achieve the kind of print speeds that are going to be supported by being able to move things around in 3 dimensions easier.
If you look at big industrial CNC machines, they move at the kind of speeds that we're talking about here and are incredibly rigid, rigid enough to mill steel instead of just lay down a little noodle of melted plastic. Building the machine that is sturdy enough to do this shouldn't be a problem. Part of the problem has always been doing it on a budget that 3D printer enthusiasts or would-be 3D printer enthusiasts find tolerable. And a lot of it's also been because we've been doing this at home. I mean, all these innovations here have come out of the home gamer scene, from input shaping, pressure advance. When we see these cool things show up in the kind of mass market consumer 3D printers out there, they're already kind of a year or two old on the, in the 3D printer DIY enthusiast scene. And I think that's a neat angle here too, is that all of these features together have been kind of available to a bunch of people for the past 4 or 5 years. And what we're seeing here now is the kind of commercialization of the hard work that a bunch of hackers have been doing for themselves. And so the broad masses get the benefit of this. You're not so elite with your input pressure shaping now. Everybody's got input pressure shaping, but that's like a total win for the world of 3D printing. I've never been like the speed demon guy. I always just let my 3D printing jobs run overnight anyway. Like, I don't care. I'm asleep. I got 8 hours. I got to sleep for 8 hours one way or the other. I leave the thing running up here. It's in the office. It can't even hear it when your eyes are closed and you're snoring. So, it's no problem at all. But I understand I want to print this thing out now and get it done. And I absolutely understand that too. I think this is a win for everybody.
My pick this week is Tom Nardi's The Past, Present, and Future of Inflatable Space Habitats. Right up front, you got to say, and we say it a lot, but we don't say it nearly enough. Way to go, Joe Kim, on the art on this one. He's got a bunch of astronauts floating around inside a balloon animal spaceship. I mean, perfect. Now, when I first saw this, I thought about Echo 1, which was a satellite program in the 1960s that put inflatable passive balloons up in space that were basically just Mylar-coated reflectors. And this is not what this is. This is about making human-occupied volumes in space and make them inflatable. I didn't realize that we did have such a history of doing this. And there's a reason for that because, well, we've been doing it that long, but we haven't actually successfully been doing it until very recently. This article came about because of Sierra Space doing a destructive test on one of their 8.2 meter diameter large integrated flexible environment modules, LIFE. You got to have a catchy acronym for projects like this, and LIFE kind of fills the bill. This is basically a gigantic balloon that they inflated on the ground, not in space. They were figuring that it was going to be exploding at about 61 psi. It actually made it to 77 psi before it destructively failed. Huge balloon popping. What more can you say? That's great, But the point of the test was to figure out what the limits were and what the consequences were of habitat exploding. And that kind of kicked off Tom thinking about, well, what other sort of habitats, inflatable habitats, might we have tried? It ends up that we go back, excluding the Echo 1 thing in the 60s because that wasn't a habitat, but there is some useful information in that project. This goes back to the early days of the space shuttle when we had to try to find something that would fit inside of the payload bay, which was about, 18 meters by not even 5 meters. Long and, capacious in length, but not so much in width. There's not much you can do in a 5 meter width of the payload bay. So you couldn't really build something rigid that would go up inside of the shuttle payload bay. You needed to find a way to either, manufacture this thing in space or condense it down, compress it down, and inflatable seemed to make sense. So the Transhab was the first attempt at doing this. Honestly, the artist's conception of what this thing looked like were pretty awesome. There's a ton of space inside these things, and they had individual floors, individual rooms, and this whole thing basically is a big cylindrical bag. Kind of looks like a propane tank, to tell you the truth. But it's a cylindrical bag that inflates from around a central core, a rigid central core, and provides an enormous amount of space for astronauts to do work. This was at one point planned to go and be part of the ISS. Congress had other ideas about that and ordered NASA to stop doing any work on inflatable modules in the year 2000. So back to the drawing board, what is the ISS going to look like? And basically the way the ISS looks now is it's a series of tubes, but they're all tubes that basically fit inside of the shuttle bay. So they're narrow. There's no real habitat module in the ISS. And astronauts aboard the ISS pretty much just sleep in and among the equipment wherever they can. They've got the sleeping bags that kind of hang from the walls and keep them restrained while they sleep. But there's no real, this is a place that we live in the ISS. And I think that's always been sort of a detriment to the science that's going on there. Because, I mean, even if you think about Antarctic exploration, there's places in each one of the polar bases where people can, go and be alone and think about their work or do some quiet work along with common spaces. But everything on the ISS is a common space. Nobody has a private space, really. And I think that's probably a detriment to the goals of the ISS.
I love the idea of inflatable space habitats, because, you've got the pressure. It's easy to make the pressure difference in space because, mostly vacuum, right? And so it's really a fantastic fit in that sense. And, it's self-supported from the inside, so you don't have to worry about gravity, lots of space for people. I really don't want the balloon to pop. It really makes me tremendously nervous. And so that, like you said, that was the jumping off point for this article, was a test of that, big space habitat to see at what pressure it actually does pop. But, you have to worry about all the space junk out there hitting it, and who knows what kind of sharp crap it is. If it's tough enough and elastic enough, though, I guess you don't have to worry about that. And so I think it's really, it's really quite interesting to think about this.
And this doesn't really just have to be orbital space exploration that benefits from inflatable habitats. I mean, why not the moon? Why not on Mars? I mean, that was a central plot element in The Martian, right? Andy Weir came up with these inflatable habitats on Mars and made that a plot point. I could see that. I mean, there's a ton of ways to look at this, and there's a ton of places for this to go. It's on its way, probably, but and obviously we're going to have to do it in near space. But I think with Artemis, maybe we will see inflatable habitats on the moon at some point. Maybe there'll be a technology demonstrator.
Yeah, right.
Getting back to where we started this whole thing, right?
Yeah,
we'll see.
Meet you in the balloon on the moon.
Popular hit song from 2037.
I'm going soon to the balloon on the moon. Okay, I'm done now. I'm really done now. That's about it for this week's Hackaday podcast. Thanks very much for listening. If you want to follow along with the show notes or drop us a suggestion for next week's Ask Me Anything, head on over to hackaday.com/podcast. And as always, if you see anything cool or do anything cool, send us an email to tips@hackaday.com, and
keep on hacking.
For real this time. Yeah.
I'll go back in time here and...
Do you want to predict the future? It's rigged. I think that's it. I think we're set. Let's see. What was I going to say about this? Give me 1 sec. I'm going to take a drink. I'm going to step back. I'm going to think first, talk second.
Dum, 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 dum.
We've got everything else except rain in LA.
Flying police cars. Not so much.
What is this? It's topology? What is this shape? Maybe I'm just going to skip this one. Helical antennas are... Nope, I'm done. I give up.
The past, present, and future of inflatable